Wireless charging is a total illusion. Think about it. Your charging pad is plugged into the wall with a thick plastic cable. Your phone is resting flat against a solid piece of rubber. No glowing beams of electricity are jumping through the air. So, if no power is actually leaving the pad, how is your phone's battery filling up? The truth is, your wireless charger isn't a modern digital trick at all. It's a century-old obsession that drove its inventor to madness. Today, we are peeling back the glass to uncover the hidden micromechanics of wireless power. We'll expose the secret corporate war over who actually built the first wireless phone, why your charger used to get dangerously hot, and the bizarre 19th century physics that makes it all possible. Because the gadget on your nightstand isn't just an accessory, it's a high-stakes safety engine. To understand how this works, we have to travel back over 120 years to a man who wanted to give the entire planet wireless electricity for free, Nikola Tesla. In the 1890s, Tesla discovered something shocking. He realized that if you pump a high-frequency alternating current through a giant copper coil, you create a fluctuating magnetic field. He proved it by standing in his lab holding completely wireless, disconnected gas bulbs and making them glow into life just by standing near his machine. It was called resonant inductive coupling. Tesla dreamed of shooting this power across oceans using the Earth's atmosphere. He failed, went bankrupt, and died penniless. But his core blueprint didn't die. Today, engineers have taken Tesla's massive, room-sized tower, shrunk it down to the thickness of a coin, and shoved it directly inside your pocket. Here is the exact mechanical ballet happening right now. When your pad draws power from the wall, it pushes alternating current into its copper coil. This current changes direction violently, thousands of times every second. This frantic motion forces an invisible magnetic field to bloom upward out of the plastic. The moment you place your phone down, its internal receiver coil catches that moving magnetic field. Because of the laws of physics, a moving magnetic field forces stagnant electrons to start running. Just like that, magnetism turns back into pure electricity, flows into your battery chip, and recharges your phone. No sparks, no open plugs, just pure, silent induction. But bringing this to smartphones caused a brutal corporate dogfight. If you ask most people who did wireless charging first, they'll say Apple or Samsung. They are completely wrong. The actual pioneer was a forgotten underdog, the Palm Pre in 2009. Long before the iPhone even had a Retina display, Palm launched the Touchstone system. It used an optional back cover with a built-in coil that magnetically snapped onto a tilted charging stone. It was beautiful. It was futuristic. And it completely crashed and burned because the public wasn't ready. It took 3 more years for Nokia to make it universal in 2012 with the Lumia 920, the world's first phone with the universal Qi standard built right into the body. Suddenly, the wireless race was blown wide open. But as everyone rushed to adopt it, a glaring engineering flaw drove users insane. Have you ever picked up your phone from a wireless pad and noticed it felt shockingly hot, but your battery barely filled up? If those 2 copper coils miss each other by even 2 millimeters, the magnetic field misses its target. That stray energy doesn't just vanish, it bleeds into the surrounding copper, aluminum, and glass, converting itself into pure, destructive heat. This heat bakes your lithium-ion battery, drastically shortening its lifespan. To save itself, your phone violently throttles its charging speed to a crawl. This is why the tech world united to create the modern Qi2 standard. By integrating a precise ring of microscopic magnets around the coils, your phone is physically forced into a perfect mathematical bullseye every single time. Zero wasted energy, zero destructive heat, and a massive jump to 25-watt speeds, finally killing the wired cable for good.
But think about the danger here. If this pad is constantly throwing out a powerful, metal-exciting magnetic field, why doesn't a stray coin or paperclip left on it turn into a red-hot piece of molten metal that sets your desk on fire?
Engineers built an unyielding defense mechanism called foreign object detection. Before the pad allows high-voltage electricity to enter the coil, it sends out a tiny, low-power digital ping. It is screaming out for an encoded digital handshake from your phone's processor. If it hears nothing, or if it senses even a micro disruption in the magnetic field caused by a coin, it completely cuts the power. It is an incredibly smart, split-second piece of communication, keeping you safe while you sleep. So, the next time you drop your phone down and listen to that satisfying magnetic click, remember, you aren't just using a basic phone accessory. You are using a highly evolved, scaled-down version of Nikola Tesla's wildest dream.
If you want to keep unmasking the invisible engineering that runs our modern world, hit that subscribe button right now.
This is Factually, and we'll see you in the next machine.